Hi, my name is Lara Newsom. I am a software engineer on the customer experience team at Cisco, and the talk I have for you today is called Autoscale Your App Without Supersizing Your Budget. Now, the idea behind this talk came because I am a developer and I deploy a lot of work to the cloud, and I have no idea how much it costs to run my work on the cloud. And I feel like this is something that I should care about as a developer. And there's a reason for that, right? Because in 2021, they are predicting that cloud providers will be pulling in $250 billion in revenue, right? That's a lot of money. In 2017, AWS revealed that 35% of cloud spend is wastage. So cloud spend is just another way to say your cloud bill, right? But 35% of that's just going right down the drain. That's a lot of money, right? 70% of all tech spending is on cloud initiatives. So that's a lot of money for companies, especially smaller and medium-sized companies, to just be kind of throwing away all the time, right? So how did we get here? And I think we'll just go back to the beginning, like how this all came up. So back in the olden days, when I started writing code, most companies had their own on-prem servers. Now, I recently listened to a podcast where they referred to on-prem servers as the private cloud, which I thought was genius because I swear I have several dozen family members that believe that the cloud is a nebulous, magical computer land where things happen on the internets, right? So really, the cloud it's just a big warehouse full of the same servers that our companies used to keep in closets, right? So back in the olden days, companies kept their fancy servers in their closets, and those servers were expensive. I don't know if you've ever been involved in requisitioning a new server for your company, but it's like tens of thousands of dollars to obtain a new server, and sometimes those servers comes with licensing fees as well. But that cost, although it was high up front, it was predictable and it was manageable. A lot of these companies also employed people on staff, DBAs, IT staff, to sort of manage patching, networking, firewalls, all that sort of stuff that went along with owning your own server. As far as the developers were concerned, our development lifecycle went sort of like this. It was like business would call and they'd say, hey, we want this new feature and here's your deadline. And I'd be like, cool beans. All right, I'm gonna work on that. And I'd start working on it and I might deploy it to dev. I might have a dev server I can deploy it to. When I get it all ready, I deploy it to prod and I'm like, yay, it's in prod, and then everyone's happy and the code is running because usually there wasn't a problem with resources. Every now and then you might run into an app that was like a real resource hog and you'd be like, oh my gosh, we have to get another server, right? But that usually didn't happen, especially with kind of smaller companies. So for on-prem, the actual cost of running the app was sort of known, right? It was sort of just, we paid for the server already, we've already absorbed that into our budget. It's not going to cost us any more to deploy this new feature. So I think of that sort of like a sushi boat, right? So if we're gonna put it on a menu, it's gonna be like sushi boat style, where you get a whole lot you might pay more for it. It's an upfront cost, but you know what you're gonna get, and it's gonna be a lot, right? So like the sushi boat, you're gonna get all kinds of rolls and pieces of sushi and sashimi. You might get some edamame, I don't know, pickled ginger, right? It all comes on the boat. If you eat it all, great. If you don't, it's there for later. But then and the cloud comes into the scene, right? Now, the great thing about the cloud was that it allowed smaller companies easy access to the internet. It's a really low bar of entry financially to get in, right? Because there's even free tiers, right? So that's really great. There's also like no risk for trying out these new services. So I don't know if you can imagine calling up Microsoft and being like, hey, Microsoft, I sure would like to try out one of your servers for a month, and then maybe I'll return it if I don't like it. Like, that's not a thing that's going to happen. With on-prem hardware especially, you are going to buy it and you're going to use it and you're going to like it, right? Whereas with the cloud, you can say, maybe I want to try this service and see if it works for my stack. And if it doesn't, I'm still in the free tier, so it doesn't matter, so I'll just turn it off, right? So it's kind of this whole new way of thinking about adding pieces to your stack, about your development environment, right? It also sort of came with a whole new set of expertise to manage. Now, some of the knowledge that a traditional DBA or on-prem like IT staff has would definitely transfer to the cloud. But there's all these other things that we have to manage within the cloud. And the actual cost of running apps on the cloud is really not known until they're being used at scale in prod. There are ways to do stress testing. You can maybe sort of estimate what you think your traffic is going to be, but anyone who's ever deployed an API to the cloud knows that sometimes it surprises you, right? And so I like to think of the pricing system for the cloud as more of a sushi conveyor belt restaurant. So I don't know if you've ever been to one of these, but they're kind of great. You've got the sushi bar in the middle, and then all around the sushi bar is a method of conveyance, right? So sometimes it's just a kind of a boring conveyor belt, but other times it's like a moat and there's these boats chained together and they go around, and so the sushi chef is putting plates of sushi on. And now the customers are all sitting around, and each plate is really only like $1, $2, $3, maybe $5 if it's super fancy, right? But as a consumer, you can say, oh, look, there's some salmon. I think I'll have some salmon. So it's not very much money to get started eating at a sushi conveyor restaurant. But if you keep grabbing everything you want, it adds up quickly. Say you don't give clear instructions. Like one time I took my kids to the sushi bar with me, the sushi conveyor belt, and I mentioned, ooh, I like mochi. And then before I knew it, I had 5 plates of mochi, and that was like 5 plates more than I really wanted, right? So I didn't give clear instructions, and I sort of accidentally consumed more than I meant to. So in the cloud, we get our apps deployed. We have our stuff is working in the cloud, right? And as developers, we may not actually become aware of how much we're spending until we get that phone call from business, and they're like, hello, yeah, your stuff costs too much to run. I'm gonna need you to do something about it. And then I look at them like a deer in the headlights, right? Because I'm like, oh, hold up, I've never done this before. And that's sort of the cloud cost conundrum, right? The developers often shoulder the burden of cost mitigation, but they're also the ones that have the least amount of visibility into what the bill is, and they're sort of left with few resources to reduce that spend effectively. This is why development for the cloud requires a whole new layer of planning to prevent runaway spend. Now, if you're really lucky and you get into a project like at the base level and you're like, okay, we're gonna put this brand new thing into the cloud, then you have the opportunity to plan for it. The first question you should always ask is, what is the smallest service that works? What's the least elaborate way for me to get this code into the cloud, right? Do I really need Kubernetes? I mean, Kubernetes is really cool, but do you need it, right? Do you need that EC3 instance, or can you run serverless? Follow the Yagni principle. You aren't gonna need it, right? If you don't need it right now, don't go get it. Lovely thing about the cloud is that if you need it later, you can add it later. It's there, it's waiting for you, and they would love for you to give them your money, right? This isn't necessarily always the situation we're in. So we have to start to think about ways to get what we're already spending under control. And so really one of the first steps is understand the pricing structures. So how are cloud costs calculated? Is it per hour, per minute, per second, per request, per amount? And the answer to that is it depends. The different services have different pricing structures. So a compute instance is going to be charging you per hour, per unit of time, right? Whereas a storage instance is going to be charging you per amount. And really, like, none of these models are very straightforward. Some of them have free tiers. Prices can vary between geographical regions. So deploying your app in Ohio might be more expensive than deploying your app on a server in China. The time of day can cost money. Reading data is always going to cost more than writing. And then luckily the billing often lacks granular visibility. So the basic billing that comes out of any of the cloud providers is kind of like, here's how much you spent this month. And you're like, cool, what'd I spend it on? And they're like, all this stuff. You know, it's not laid out piece by piece. But, you know, cost confusion is really just one of the causes of cloud spend wastage. There's other culprits. We've got unused resources, right? Unused environments. I have several companies that I worked for that spun up QA environments and had the entire stack running in them and never used them, right? That cost money. Unused running instances. I actually had an API that we were migrating from one instance to another, and we forgot to turn it off. So that thing ran for 6 months and nothing was hitting it. It wasn't having any traffic, but it was there costing the company money, right? Idle load balancers can cost you money. Unattached storage volumes cost you money. Obsolete snapshots cost you money. So you're kind of probably noticing a trend here. It's like if you say I'm going to use something, even if you don't actually use it, you're going to pay for it. Over-provisioned resources is another problem. So this is where like setting and forgetting comes in. A lot of the teams I've been on, we set up Helm charts. You know, for like Kubernetes, Helm is great because you can sort of set up some sort of like the basic requirements needed to run an API or a UI in your specific environment. And part of that is setting some default resource values for the pods, right? So you'll set your CPU and your memory and the minimum number of pods. And so when we make Helm charts, we sort of try to set those at reasonable amounts. Like if you're an average API, this is about how much compute you should use. This is about how much memory you should use, right? And you're probably gonna need, maybe you'll need 2 pods. I don't know, right? But if you set that and then you never go back and evaluate if you're actually using that much of your resources, you might be wasting money. All of those things end up costing money. It's not what you actually use, it's what you say you're going to use. So keep that in mind. Mismanaged resources is another way that we end up wasting money on the cloud. On-demand instances, compute instances are way more expensive than something like spot instances or reserved instances. For example, you could use spot instances instead of on-demand. So a spot instance, so think of like a theater, and when people come in groups and they buy chunks of seats, right? And so there's always that 1 or 2 seats left between groups of people. And so that's kind of how spot instances work, because the other thing that happens with the cloud is there's auto-scaling, which is wonderful, right? Because if you need 5 pods at noon, but you need 1 pod at midnight, it'll scale it up and down for you, right? So there tends to be these lulls in resource usage, and the cloud providers can provide spot instances to run non-vital tasks in these windows, in these like single seats between the groups, right? Give you a huge discount for that kind of stuff, like up to 90% off, right? So that's a great deal. Making expensive data transfers. So if you transfer 1 file at a time, it's more money than transferring a directory, right? So kind of keep that stuff in mind. And also just using the wrong type of service. Are you using a storage instance that's inappropriate for the job that you're doing, right? Like, did you look at those deep storage instances and think, this is great, like these are super cheap to store stuff in, and then you realize that every read out of there is really, really expensive, right? Like that's not what they're meant for. So that would be mismanaging, right? And then we have my favorite set of mistakes, which are the developer mistakes. Writing computationally inefficient code. I am very guilty of this. In fact, one time I brought down a Redis pod in 30 seconds. So basically what had happened was that we had a new API that we were spinning up, and it was midnight, we're releasing this thing into the wild. And so this API, it was making calls to a third-party provider, and there was one call in particular that would have been made a lot, and it always fetched the same data. So we thought, this is the perfect use for a Redis cache. We're gonna take that blob and we're gonna stash it in Redis, and then when we need it, we'll just get it out of Redis, which is a much faster read, and then carry on our merry way. Now this worked really great with our legacy app, because the legacy app wanted that whole blob, and then it was actually doing a link merge in the legacy app. So that was the perfect use case for that. I failed to notice that the mobile app was sending requests with 1 ID at a time. And it was sending like 1,000 a second, right? So kind of a lot. And so it was sending these requests over, and it was trying to read the 2 megabyte blob out of Redis 1,000 times a second. And you'll be shocked to hear if that made Redis fall down, right? So I needed to go in and refactor my code to actually store off each ID in Redis so that when our mobile app hit, it wasn't getting the entire blob every time, right? That was a computational problem, right? Another problem that developers have is chatty logs. Our endpoint that was getting called 1,000 times a second was logging every time it called, right? We didn't need those logs. In fact, every time we'd look at the logs, we would filter them out. I'm going to link you to an article that Harness wrote. They actually went into their logs and investigated all of the logging that was happening for their applications. And what they realized is that by changing the way they were logging, sort of moving some of the logs to other places, they were able to save $140,000 a year, right? That's a significant amount of money, especially for smaller companies. Like that's you can pretty much get a developer on staff for that, right? So that's a lot of money to be throwing away just so you can log the same endpoint 1,000 times a second. Another developer mistake is not understanding your network traffic. Are your requests doing a lot of reading from databases? Are they, where are they coming from, right? So these are all questions we need to know when we're deciding not only where we're running our instances, but how we're writing our code. The best place for me to really start controlling the costs of my services is to understand what my costs have been and where I'm spending money. And the best way to do that is visibility, right? Visibility is key. There's two ways to get more visibility. I am going to emphatically suggest both of them. The first is to use a tool that provides granular visibility. And then the second is to implement comprehensive tagging of resources. Now, I don't feel like this can really be an either or. I feel like this should always be an and. You do you, right? So what tools are available? Let's talk about those. Built-in tools. We've got AWS Cost Explorer, we've got GCP Billing, and we've got Azure Cost Management. These are great tools. They are free within the platform. All three of them require good tagging. So that's one of the reasons why it's not an either or. One thing they won't do, however, it turns out AWS doesn't care how much money you spend on Google, so they're not going to monitor Google for you, right? So that's when we start looking at external tools. Datadog, Cloudability, Cloud Admin, Harness, Cloud Checker, Cloud Health, KubeCost, Densify, Flexera, right? There's actually a significantly longer list that I could keep appending onto there. But the point is that there are tools out there in the world, and a lot of them provide really great dashboards to really help you visualize your data. Some of them allow you to monitor resource across platforms. Actually all the tools will give you actionable advice to reduce your spend. So even the built-in tools will give you that. So if AWS Cost Explorer is like, hey, I noticed that you're running this compute instance on an extra large instance, and I think you could probably do it on a large, right? They'll give you that advice. Some of the tools will give you improved alerting, right? So it can let you know when you're getting close to budget thresholds. It can let you know when there's like weird stuff happening. And some of them are really good at budget forecasting, right? So that your accounting team is gonna love that. If they can have some general sense of what your apps are gonna cost them for the rest of the year, it makes it easier to plan, right? But the one I really appreciate as a developer are the tools that can give you real-time visibility into costs. So if I can push some code up and I can immediately see what the effect of that code is, that's awesome, right? Because otherwise I kind of got to wait. And so it's like, I pushed a change and now I'm going to wait, and I'm going to push another change and now I'm going to wait, right? So like, I want feedback immediately. I want that feedback loop to be tightened up. And so that tightens up that feedback loop. So my advice on these tools, I'm not going to tell you which one to use because I don't know your stack. I don't know your team, right? I don't know your company. I don't know what your budget's like, right? But what I can say is there are a lot of resources out there that compare these different tools, and it's really worth investigating to sort of help you understand your cloud spend, right? But now let's get to the really important part, which is tagging and labeling. Now you'll notice I've added and labeling on there, and that is because for AWS and Azure, it's tagging. GCP has tagging, but it means something totally different. They want you to use the word labeling. So if you're searching for GCP tagging, you're gonna pull up something that's not what you're looking for. So I'm gonna use tagging here, but know that if you're on Google, you need to be looking at labeling your resources. So why tags, right? The biggest thing is they do cost roll-ups for each group in your monthly bills. So you can get really good data of like, oh look, hey, my preferences API, this is exactly how much it costs this month. It looks like everything that's running in dev is costing us this much, right? So you can help clearly separate costs by department, by team, by service, right? Accounting is going to love that because they love to put costs where they belong. And so being able to separate out and be like, hey team that's working on this API, your API costs a lot more than every other API in this company. In addition to cost, these tags can help with application security, with compliance, configuration management, change management, audit programs, backup management. Tagging allows quick access to specific parts of your stack, right? So there's really no reason to not do tagging or labeling. So what's your tagging plan, right? If you don't already have a tagging plan in place, you need one, right? So how do you do that? So what tags do you need? What do you care about? How are costs divided? Like, that's a good place to start. Like, how do you have different environments? It'd be good to know if you've got environments running. Like, for example, an unused QA environment might be nice to know about, right? And then how do you handle alerting? Do you want to actually just alert the entire team? Do you want to do Slack alerts? Like, how do you want to handle that? Good tag hygiene. Number one, never, ever, ever put PII or secrets in your tags. These are publicly available. Well, not publicly available, but they go out into your billing department. Like, people don't need these secrets. So tags are in key value pairs. Each of the platforms has sort of specific rules you need to follow as far as how long they can be, what kind of characters they can contain. So look it up for your specific platform. Tags are also account specific, right? So if you have different accounts, naming the services in the different accounts with the same name is going to help you match them up. And then I think most importantly are the naming conventions. Number one step, prefix your tag with the source, right? AWS : blah, 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 blah. GCP : blah, 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 blah. Now, if you are only on AWS, it might seem silly to be tagging it that way, but you don't know if someday you might have resources coming from someplace else, right? So what if you also have something deployed on Google? What if you have some on-prem stuff, right? So prefixing your tag is just good hygiene, right? Don't forget that tags are case sensitive.
We should avoid tag sprawl, which is basically where instead of making individual tags for each piece of information, you try to gang those up on a single tag. So for example, if you have a developer that should be contacted if something goes wrong, and you try to put their name, email, and phone number all on a single tag, that doesn't really make sense. Since each resource can have up to 50 tags, there's no reason to not separate those out into individual tags. So all the naming conventions in the world won't make a difference if we're not actually enforcing tagging and labeling within our pipelines. And so this is where we can really take advantage of infrastructure as code services like Terraform, CloudFormation, Ansible to really set up the pipeline to enforce tagging, to enforce labeling of whatever we're deploying, right? And then a big part of tagging and labeling is going to be actively managing that tagging, right? And so part of that is going to be auditing. So we can take advantage of auditing software such as Cloud Custodian, Cloud Forecast, AWS, Config Rules. There's a lot of different software out there that'll help perform regular audits on the tags to make sure that they are up to date.
So once we've got our tags in place, once we've sort of identified what our problems are, right? Like where are we wasting money? What do we do about that now? So this is where we get into concepts like right sizing. So right sizing is where that real-time reporting can come in handy because you can get immediate feedback. If you bump down your CPU, is that gonna make stuff break? You know, like, am I gonna break stuff if I change these settings? So getting that real-time feedback is really great. And you can kind of get a sense of that from the real-time reporting right away, as opposed to if you're using one of the built-in resources, there's a little bit of lag time there. This is also where autoscaling is great. Like, autoscaling is amazing, and you should totally take advantage of it if you can, right? Because this will help your apps automatically go. So if you have a spike of traffic every day at noon, and by midnight you're almost down to nothing, this will help auto-scale. This will scale your resources up and scale them down, because remember, with a compute instance, you're paying for time, right? They don't care that it's not that it exists, it's how much time you spend on there. Because remember, they have those spot instances they can sell off, right? You can also, this is where you can be changing your default allocations. Maybe you can just reduce your number of instances. Like, do you need that many nodes running? Or could you maybe take the unused resources running on 3 nodes and combine them into 2? So there's some different ideas that you can investigate. And luckily, if you're using one of the tools, they'll just straight up suggest them to you, right? So that's one way. Then we have to consider properly shutting down unused resources. So the reason I had my old API running for 6 months unnoticed was because when it was time to do the switch over and we were meant to turn that off, I'm pretty sure we just went in and killed the container. And so the pipeline looked at that and was like, oh, hey, I noticed that your container is not running. Don't worry about that. I'm going to go ahead and spin that right back up for you. And that's what happened. And so then that thing was just running and we didn't realize it. Now, if we had had good labeling on there and had been able to investigate the bills coming in, we would have known that was still running and still costing us money, right? But when you've got unused resources like this, the best idea is to shut them down with the resources, the same tools that started them, right? So shut down your resources with the same tools that started them. This will help remove them correctly so they don't just very helpfully spin themselves right back up again, because the cloud is really meant to recover, right? It's meant to, if you crash, if something falls down, it's supposed to be able to get back up again. Another way to reduce your spend once you kind of have some visibility is to reevaluate your service options. So a lot of the cost savings suggestions that you're going to be getting may be to switch instances, right? So you may be using a lot of on-demand instances and you don't need them, right? So if you're running a cron job that doesn't really matter when it runs, it just has to run sometime, right? You can use those spot instances. Remember, that's like the theater seats, the unsold theater seats. If you know you're going to use a certain amount of resources over the course of a year, you can buy reserved instances, right? So that's kind of like gas futures. Gas futures is probably not a very helpful comparison because that's also very confusing, but basically it's like saying, I know I'm going to need 500 gallons of gas this year. I see that right now it's $2 a gallon. I'm going to guarantee I'm going to buy 500 gallons and you're going to guarantee that I'm going to pay $2 a gallon for it, right? And so reserved instances are the same thing where you're like, I know I'm going to use this much this year and I want a deal on it. And they do that, right? There's also bulk pricing. So really big companies can start to take advantage of bulk pricing. Huge companies pay a much lower percentage of their budgets in cloud spend than smaller companies do because they can take advantage of bulk pricing and reserved instances. You may also want to look at changing services, right? Or I'm sorry, changing regions, right? So if you're deployed in an expensive region and it turns out you could probably get away with using a different region, it's worth exploring, right? You can also be looking at, am I using the right storage bucket, right? And so these are all suggestions that you're going to be getting out of tools. And they're also things that you can evaluate and try. And then there's my favorite, which I have the most control over as a developer, which is refactoring. So identify your heavy CPU usage. If you've got two very similar APIs and one of them is using like twice the resources that the other one was, maybe start looking at that code and see if there's something wrong with it. Like, is somebody, what's your big O look like? You know, somebody looping through, right? Really knowing your data. So the API that I made the Redis pod fall down for, we didn't realize that the prod data was actually going to hold, was going to be 2 megabytes, like because the dev data we had was more like 50K, right? So it was a significantly smaller blob, right? So understanding what you can expect in production is also very helpful. Maybe you can leverage local caching, like taking advantage of something like Redis or Postgres. Instead of making network calls out to always fetch the same data, maybe you can store it locally, right? So those are all ways that you can sort of refactor your code. One thing that we actually did, it was the same API. It had some problems, right? So we were storing secrets in Vault to be able to call the third-party provider. Well, the Vault instance was not in the same instance that the API was running in. So we were making these really expensive calls out to Vault over and over and over again, when really what we needed to do was move those Vault secrets into the instance that we were running. And that's what we did. And we actually went from running 6 pods to 2, right? So that was a huge amount of money that we were kind of just wasting because we kind of made this boneheaded mistake. So these are all ways that you can refactor your code and end up saving money, right? But the most important takeaway, that if you take nothing else away from this talk today, is that cloud cost optimization is an ongoing task. It needs to be built into our development lifecycle from the very beginning, and it needs to be maintained as really like tech debt the whole time, right? It's something we always need to monitor and something we always need to stay on top of, because at any point, the way that our services are being used can change. The way we may push a change and find out, oh, oops, that was a big mistake. Look what I've done, right? So keeping a close eye on the resources that you're using, setting yourself up to be able to monitor those resources is the best way to set yourself up to being successful in cloud cost optimization.
I have a list of articles that I found helpful when I was developing this talk that I'd like to share with you. I acknowledge that this is a video and you cannot click any of these links. Therefore, I've also provided a QR code here to be able to scan this and access the slide deck directly.
So that's all I have for you today. I hope you've gotten something out of this talk, and I hope you enjoy the rest of your conference.
Hey, it's Joe Eames with ng-conf. If you like that video, be sure to click subscribe either here or here, somewhere over here. And if you're looking for something more, here's another video for you to watch here or there or somewhere.